Hi, Arya. So you have three definite integrals that you know the value of, and now it's asking you for the value of this new definite integral, but you don't know what f, g, and h are. You just know the value of the integrals. First off, there's probably a little pop-up that's blocking my face. That is a glitch in Wyzant that there's nothing I can do about. So that's happening to everyone across the board. So here it is. Here's my face. Sorry you can't see it, but for the purposes of this video, we should be just fine. Okay. So the nice thing about integrals is in this way, they work exactly like derivatives do. So you might have recalled there's something called the sum rule for derivatives, but the way you probably remember it is that you just do term by term integration. So remember back to when you first started doing derivatives and you were doing polynomials, we said, okay, it's okay just to integrate each term of the polynomial separately. You don't have to worry about them. You just do them one at a time. So in this way, integrals work the same exact way. Sometimes they work in weird, more complicated ways, but in this sense, they work the way you would want it to. Just sometimes math behaves. Okay, so that's the first thing, is you can just split this up into three totally separate integrals and deal with them separately. The other nice thing is something called a constant rule, which says, okay, just like with derivatives, if you know the derivative of x to the fifth, you also know the derivative of like 3x to the fifth because you just multiply that thing by 3. So same thing with integrals. You just, you can bring constants to the outside, and you can and should. You should bring constants to the outside because it makes your life simpler and easier. And then just say, okay, well, since I know what the integral of f of x is, I know what the integral of 4 times f of x is. So remember what definite integrals are. They're just an area. So all you're really doing in this problem is adding the areas of shapes. And what this rule says is, if I know the area of a shape and I multiply that thing by 4, then the area of the area just gets multiplied by 4 as well. Think about just like taking a rectangle and like timesing it by 4. It just gets 4 times bigger, and literally 4 times bigger. So the area grows by 4 as well. So that's all this is saying, is we're adding the areas of 3 shapes. You don't know what they are, but you know what the area is. And we're saying if you stretch it out by a factor of 4 or 2 or whatever, then the same thing happens to the area. And if you subtract it, then that same thing happens. You're just subtracting the area of some other shape. So I'll come up here. This equals 4 times, well, you know what these things are. So I haven't written the bounds because it just looks messy. So the negative 68 and the negative 32 don't matter at all. All that matters is that the bounds are the same for everything you're looking for. So this is just 4 times 11 plus 2 times 20 minus 28. And that's just a simple calculation. So 44 plus, let's actually do it just for thoroughness' sake. 44 plus 40 is 88 minus 28 is 60. Okay, and there you go. So treat integrals exactly like you would derivatives. Just split them up, bring constants to the outside. When you get into products, like remember the product rule for doing derivatives is totally different, and you can't really do that with integrals, and that's why Calc 2 is harder than Calc 1. Okay, thank you.